I was looking at photos of the Empire State Building's construction the other day.
Oh, yeah, the guy's dangling off the steel beams.
Exactly. Zero safety harnesses, just eating lunch 1,000 feet up. But the thing that really hit me was, well, there are no computers.
Right.
If you walked into the engineering office that actually designed that beast, you wouldn't hear, a single server fan. No clicking keyboards.
Just that rhythmic shh
Yeah.
sound, which is it's what some historians call logarithmic silence. Because for about 350 years, that quiet sliding of wood and bamboo, that was the soundtrack of the industrial world.
Right, because we're talking about the slide rule, or the slipstick, as the old school engineers called it.
The slipstick, yeah.
Yeah.
It wasn't just a ruler. It was essentially the primary analog computer for centuries.
And for this deep dive, we really want to unpack how this simple piece of wood bridged the Industrial Revolution and the space race.
Because if it was engineered before the 1970s, it was calculated on a slide rule.
So let's get into the mechanics of this genius.
Mhm.
Because I've seen these things in museums, and honestly, it looks like a ruler having a midlife crisis.
Just numbers everywhere.
Everywhere, just crammed together. How does sliding a stick actually do math?
Well, it's all about logarithms.
Yeah.
But let's skip the dry textbook definition and just visualize it for a second.
Okay, I'm with you.
Imagine two rulers, one on top of the other. But the numbers aren't spaced evenly like on your normal tape measure. They get crunched closer together the higher they go.
Got it.
So if you want to multiply 2 by 3, you slide the top ruler so its start line, the 1, aligns with the 2 on the bottom ruler.
Okay.
Then you just look over the 3 on the top ruler and look directly down. And it aligns perfectly with 6 on the bottom.
Oh, wow. So you haven't really done multiplication.
No, you've physically added the length of the number 2 to the length of the number 3.
That is incredibly clever. You're turning complex multiplication into simple physical addition.
Exactly. John Napier figured out the math way back in 1617, and William Otridge built the actual device shortly after. But there is a massive catch.
Oh.
The slide rule does not give you the decimal point.
Wait, what?
It only gives you these significant digits. So if you multiply 2 by 3, it shows 6. But if you multiply 20 by 30, it still just shows 6.
Hang on. So if I mess up the mental math,
You could be off by an entire order of magnitude, yes.
I could crash a rocket or collapse a bridge by a factor of 10.
You absolutely could. You, the human, you are the floating point processor. You have to understand the magnitude of the problem before you even touch the instrument.
That sounds terrifying.
It forced people to really know what they were doing, though. And people were virtuosos with these things. By the 1950s and 60s, this was the ultimate symbol of the engineering profession.
Right, I mean, Wernher von Braun used them for rocket trajectories.
Yes, and Buzz Aldrin famously took a Pickett N600 ES slide rule to the moon on Apollo 11.
Which is just the ultimate backup plan. A piece of aluminum and plastic in case the guidance computer fried.
And it worked. It was reliable precisely because it was simple.
It's amazing that a stick basically helped land a spaceship. Which is kind of ironic considering how fast we're moving toward completely automated digital systems today.
We really are. We've moved from manual calculation to intelligent automation, which is actually a perfect segue to our sponsor, Embersilk.
Yes, if you are looking to uncover where AI agents could make the most impact for your business or even your personal life, you really need to check them out.
Whether you need help with AI training, automation, integration, or software development, Embersilk helps you navigate that shift effortlessly.
Seriously, go check them out for all your AI needs at embersilk.com. So, jumping back to the slide rule, you mentioned the user had to track the decimal themselves. That must have totally changed how engineers thought about problems.
It did. It fostered this incredible numerical intuition. Because the device is only accurate to about 3 digits, you couldn't just blindly trust a string of numbers. You had to have a feel for the answer.
Right, so you wouldn't get an answer like 4.12345 You'd just get a little past 4.1.
Exactly. And that lack of hyper-precision was actually a massive strength.
Because it forced them to build in safety margins.
Yes. They didn't shave materials down to the microscopic decimal. They built things to last. It made math visual and tangible.
And then 1972 happens. The meteor hits.
The Silicon Eclipse. Hewlett-Packard releases the HP-35, the very first handheld scientific calculator.
And I read that it cost a fortune, like $400 back then.
It's $395. That's
Yeah.
about $3,000 in today's money. But engineers were practically pawning their wedding rings to get one.
Wow.
It wasn't just a product upgrade. It was an extinction event. Major slide rule manufacturers like Kufel and Esser, they were kings of the industry one minute, and the next, it's just over.
It's a little sad in a way.
It is, but it's also incredible progress. Digital tools are faster and far more precise. But the real legacy of the slide rule era is that intuitive feel for the numbers.
Right.
The best engineers today still have that. They use AI and supercomputers, but they know instantly when an output looks wrong because they understand the deep structure of the problem.
I love that. So we didn't lose the intuition, we just scaled it up.
We freed our brains from the drudgery of manual calculation so we could focus on the bigger picture. We stood on the shoulders of the slide rule to reach for the stars, and now our digital tools are going to help us go even further.
That is such an inspiring way to look at it. The tools evolve, but human curiosity just keeps driving us forward. If you loved this deep dive and want to keep exploring the wonders of the universe with us, please make sure you're subscribed to Intellectually Curious.
And hey, leave us a 5-star review if you can. It really does help get the word out.
Thanks for tuning in.